Right now, as you sit here, it feels as though you are simply looking out at the world, as if your eyes were windows and your mind were a quiet room behind them, faithfully receiving whatever reality chooses to send your way. It feels natural to assume that what you see, hear, and feel is what is truly there, waiting patiently to be noticed. Yet this comforting idea is one of the most convincing illusions your brain has ever produced, because the experience you call reality is not something you merely observe. It is something your brain actively creates. Every color you perceive, every sound that seems to arrive fully formed, every solid object that feels undeniably real, is the result of an ongoing act of prediction. Your brain is constantly guessing what is out there, using fragments of sensory information as clues rather than as final answers. It takes these faint signals and fills in the rest, constructing a world that feels stable, continuous, and trustworthy, even though it is being rebuilt again and again in every passing moment. What you experience is not the world as it is, but the world as your nervous system believes it must be in order to keep you alive. From the moment you open your eyes each morning, it feels as though the world simply pours into your mind, complete, finished, and unquestionable. The colors of the sky, the shape of your room, the familiar outlines of your own hands all seem to exist independently of you, waiting patiently to be noticed. This experience is so convincing that it rarely occurs to us to question it. We grow up assuming that perception is a kind of transparent window, that the mind is a quiet observer sitting behind the eyes, and that consciousness is little more than a mirror faithfully reflecting whatever is placed in front of it. Yet this intuitive picture hides a far more radical truth, one that unsettles many of our most basic assumptions about what it means to experience reality. The brain does not work like a camera, capturing a perfect copy of the world and delivering it to an inner screen. It works more like a storyteller, constantly weaving fragments of sensory input into a coherent narrative about what it believes is happening around and within you. At every instant, your nervous system is flooded with incomplete, ambiguous, and often noisy signals. Light hits the retina as shifting patterns of energy, sound vibrates tiny bones in the ear, pressure stimulates receptors in the skin, and chemical changes ripple through the body. None of these signals arrive labeled, organized, or meaningful on their own. If consciousness were truly a mirror, these fragments would feel chaotic, unstable, and deeply confusing. Instead, your experience feels smooth, structured, and meaningful because your brain is not waiting for the world to reveal itself. It is actively constructing what you perceive. This construction begins long before you become aware of anything. Based on your past experiences, your genetic makeup, your current bodily state, and the situation you find yourself in, your brain continuously generates expectations about what is likely to be happening next. These expectations are not vague guesses, but detailed internal models of the world and of your place within it. When sensory signals arrive, they are compared against these models. If they roughly match what the brain predicted, the prediction is confirmed and becomes your conscious experience. If they differ, the brain adjusts its model and updates what you perceive. What you experience as seeing, hearing, and feeling is therefore not a direct reading of reality, but the best current hypothesis your brain has formed about what must be out there. This is why two people can look at the same scene and walk away with different experiences of it. Their brains are not identical prediction machines. They carry different histories, fears, hopes, habits, and memories. One person might see a crowd as exciting and alive, another as threatening and overwhelming. One might hear criticism in a neutral comment, another might hear encouragement. These differences are not simply matters of opinion layered on top of a shared reality. They are differences in the very construction of reality as it appears in consciousness. Each brain is actively creating a version of the world that makes sense in terms of its own predictions and priorities. Illusions provide a striking demonstration of this process. When you look at a static image that appears to move, or at a flat drawing that seems three-dimensional, you are not being tricked by your eyes alone. Your brain is applying its usual predictive strategies to signals that have been carefully arranged to exploit them. It fills in motion where none exists. depth where there is only a surface, and even faces where there are only random patterns. The illusion does not reveal a failure of perception, but rather a feature of it. It shows how deeply your experience depends on internal models that guess what is likely to be present, rather than on a simple registration of what is physically there. The same constructive process operates in your experience of your own body and your sense of self. The feeling that your body belongs to you, that your thoughts are yours, and that you are a single, continuous person moving through time is not given directly by the world. It is assembled by your brain in much the same way as colors and shapes are. Your brain predicts what sensations should arise when you move, what emotions are appropriate in a given context, and what thoughts fit your personal story. When these predictions align with incoming signals, the experience of being you feels stable and real. When they are disrupted, as in certain neurological conditions or during intense stress, the sense of self can fragment, distort, or even temporarily dissolve, revealing just how actively it is being constructed. This understanding challenges the comforting idea that consciousness simply shows us the world as it truly is. Instead, it suggests that what we experience is always a model, a best guess shaped by survival needs rather than by an abstract commitment to truth. Evolution did not design the brain to deliver an objective picture of reality. It shaped it to keep the body alive long enough to reproduce. Perception therefore emphasizes what is useful, what is relevant, and what demands action, often at the expense of what is technically accurate. You do not see every wavelength of light, hear every frequency of sound, or feel every change in air pressure. You experience a carefully filtered and interpreted version of the world that highlights what matters for your biological and psychological goals. Once this is understood, the idea that consciousness is a mirror begins to look increasingly implausible. A mirror does not interpret, prioritize, or guess. It does not change its reflection based on past experience, internal needs, or expectations about the future. Your mind does all of these things constantly. It is an active participant in the creation of your lived reality, not a passive observer. It does not simply receive the world, it negotiates with it, reshaping raw sensory data into a meaningful scene in which you can move, decide, hope, fear, and plan. This perspective also explains why reality feels so immediate and undeniable even though it is constructed. Because the predictive models that shape your experience are updated continuously and operate below the level of conscious awareness, their results arrive already packaged as what is happening now. You do not experience the process of construction. You experience only the finished product. The world feels simply given because the work of building it is hidden from you, performed silently and ceaselessly by neural processes that evolved long before reflective thought. To say that consciousness is not a mirror of reality is not to say that the world does not exist or that everything is an illusion in a trivial sense. There is a world out there, independent of your mind, and your sensory systems are in constant contact with it. But the form in which that world appears to you is always shaped, filtered, and interpreted by your brain's predictions. What you live inside is not raw reality itself, but a carefully managed interface between your biological needs and the unknown environment beyond your senses. In this way, your conscious experience becomes less like a window and more like a dashboard, presenting information in a form that is useful rather than complete. It shows you what you need to know to act, to avoid danger, to seek nourishment, to connect with others, and to maintain a coherent sense of who you are. It hides the vast majority of what is physically present because most of it would be irrelevant, overwhelming, or meaningless for survival. Understanding this does not make the world feel less real. If anything, it makes your experience more remarkable. It reveals that what feels so solid, so obvious, and so immediate is the result of an extraordinary ongoing act of biological creativity. Your brain is continuously imagining a world and testing that imagination against incoming signals, adjusting its story moment by moment in order to keep you oriented, alive, and moving forward in a complex and unpredictable environment. From early childhood, we are taught, often without realizing it, to think of the brain as a receiver. The eyes collect images, the ears collect sounds, the skin collects touch, and somewhere deep inside the head, all of this information is gathered and presented to a conscious observer. This picture feels logical because it fits the way experience appears from the inside. It seems as if the world is simply delivered to you, moment by moment, and that your brain's main task is to register what is already there. Yet modern neuroscience has slowly revealed that this comforting idea is backwards. The brain is not primarily a receiver of information. It is a generator of predictions. At every instant, long before you are aware of seeing, hearing, or feeling anything, your brain is busy forecasting what it expects to encounter next. These forecasts are not casual guesses. They are highly structured models built from your past experiences, your genetic wiring, and your current bodily state. Your nervous system uses them to anticipate the likely causes of incoming sensory signals. Instead of waiting passively for the world to announce itself, your brain sends predictions down through its sensory systems, preparing them to encounter what it believes is most probable. When sensory information finally arrives, it is compared against these predictions, and the difference between what was expected and what was received becomes the key signal that drives perception and learning. This process is far more efficient than simple reception. If the brain had to process every sensory detail from scratch, you would be overwhelmed by the sheer volume of data flooding in from the environment. There are far more signals reaching your eyes, ears, and skin than you could ever consciously experience. By predicting what is likely to be there, your brain can focus its resources on what is surprising, what does not fit its expectations, and what might require immediate action. In this way, prediction is not an optional feature layered on top of perception. It is the core mechanism that makes perception possible at all. Consider something as simple as recognizing a face. You do not analyze every pixel of light hitting your retina and then slowly assemble them into a face-shaped object. Your brain already carries detailed models of what faces generally look like and of what familiar faces in particular look like. When light patterns arrive from a person standing in front of you, your brain matches them against these internal models. The experience of instantly recognizing a friend is the moment when the brain's prediction about that face is confirmed by incoming sensory data. The world seems to present itself effortlessly, but in reality your brain has done most of the work in advance. The same predictive machinery shapes your experience of motion, depth, sound, and even time. When you catch a ball, your brain is not waiting to see where the ball is at each instant and then reacting. It is predicting where the ball will be in the near future and adjusting your muscles accordingly. When you listen to someone speak, your brain anticipates the next sounds and words before they are fully spoken. This is why you can understand speech even in noisy environments and why you can finish someone's sentence when they pause. Your experience flows smoothly because your brain is constantly staying one step ahead of what it expects to encounter. Prediction also lies at the heart of how your brain regulates your internal bodily state. Your heart rate, breathing body temperature, and energy levels are not merely reactive responses to changes that have already occurred. Your brain continually predicts what your body will need in the near future and adjusts internal systems in advance. When you stand up, your brain anticipates a drop in blood pressure and increases heart rate before you become dizzy. When you prepare to run, it predicts increased energy demands and mobilizes resources accordingly. In this sense, the brain is not only predicting the external world, but also predicting and managing the internal world of the body, maintaining a delicate balance that keeps you alive. Understanding the brain as a prediction machine also changes how we think about emotion and feeling. Emotions are often treated as reactions to events that have already happened, but they too are shaped by predictive processes. Your brain anticipates the bodily changes that are likely to occur in a given situation and prepares your physiology accordingly. A feeling of anxiety before a public speech, for example, reflects your brain's prediction of potential challenges and threats, mobilizing your body for what it expects may happen. These emotional experiences are not passive reflections of reality, but active preparations for possible futures. This predictive view also helps explain why perception can be so deeply influenced by expectation, belief, and context. If your brain is constantly generating predictions, then what you expect to happen will shape what you actually experience. Placebo effects, for example, demonstrate how the belief that a treatment will help can lead to real changes in pain, mood, and even physiological measures. The brain's prediction that improvement is likely can influence bodily systems in ways that make improvement more probable. In the same way, fear can amplify pain and confidence can reduce it because your brain's forecasts alter how sensory signals are interpreted and how your body responds. When predictions and incoming signals diverge sharply, your experience can become unstable or surprising. Sudden loud noises, unexpected movements, or unfamiliar environments can feel jarring because they generate large prediction errors. Your brain must rapidly update its internal models to account for what is happening, and this updating process often arrives in consciousness as surprise, confusion, or heightened alertness. Over time, as new situations become familiar, prediction errors shrink, and your experience becomes smoother and more predictable. What once felt strange becomes normal as your brain learns to anticipate it. Seeing the brain as a prediction engine also sheds light on why change can be difficult and why habits are so powerful. Your brain's predictions are shaped by what has worked in the past. They become entrenched models that guide how you perceive and act. When you try to change a habit, you are not simply changing a behavior. You are challenging deeply ingrained predictions about what is likely, what is safe, and what is rewarding. This is why new routines can feel uncomfortable and why old patterns can persist even when you consciously want to move on. Your brain is still predicting the old future and preparing your body and mind to meet it. In this light, consciousness itself can be understood as the ongoing experience of your brain's best current predictions about what is happening and what is about to happen, both inside and outside your body. You are not merely aware of the present moment. You are aware of a moment that has already been interpreted in terms of a predicted future. What feels like no is actually the brain's constantly updated guess about the causes of its sensory inputs, shaped by memories of the past and expectations of what lies ahead. This view transforms our understanding of what it means to be a conscious being. You are not simply living in the present, passively receiving the world as it comes. You are actively inhabiting a future-oriented simulation that your brain is continuously running, refining, and testing against reality, using prediction as its fundamental operating principle. Every moment of perception, every sound we hear, every shape we see, every texture we feel is, in a sense, a construction. It feels as though the world is laid out before us in its full, objective reality, waiting patiently to be observed. Yet this sense of immediacy is deceptive. The experience of being conscious is not simply a matter of passively receiving information from the environment. Instead, what we perceive emerges from an intricate interplay between incoming sensory signals and the brain's internal predictions, a process that can be thought of as a controlled hallucination, where the mind fills in vast amounts of information to create a coherent experience of reality. The brain does not present the world as it is. It presents a version of the world that has been carefully interpreted, filtered, and supplemented based on prior knowledge, expectations, and evolutionary pressures. It constantly guesses what should be out there, and then tests these guesses against the limited, often noisy data provided by our senses. When these predictions align with incoming signals, perception feels seamless and immediate. When they do not, we notice something is off, whether it is an optical illusion, a misheard phrase, or a sudden sense of unease in a familiar environment. What is striking is that the brain's predictions dominate our experience. Raw sensory input merely refines or corrects what the mind has already constructed, and sometimes the brain ignores sensory signals entirely when they conflict with strong predictions. Perception, therefore, is not the passive reflection of reality. It is a controlled hallucination in which the brain imposes order, continuity, and meaning onto ambiguous data. Color, for instance, does not exist independently of the perceiver. The retina detects wavelengths of light, But the experience of a red apple is produced by the brain's interpretation of those wavelengths, combined with memory, context, and expectations. Similarly, when we hear speech, the sounds enter the ear as fluctuating air pressures, but what we perceive is structured language, meaning, and intention constructed in real time to match the brain's predictions about what is likely being communicated. Even the passage of time is not a purely external measure, but a subjective experience generated by the brain as it anticipates events and sequences in the environment. This controlled hallucination is shaped by evolution to prioritize survival. The brain's predictions are designed not to produce a perfect reproduction of the physical world, but a useful one that allows the organism to respond effectively to threats, opportunities, and social dynamics. Our perception emphasizes what is relevant for action, highlighting predators, allies, or sources of food, while ignoring countless details that are technically present but unnecessary for immediate survival. In this sense, what we experience is a simplified, optimized version of reality, one that balances accuracy with utility. The implications extend to the very sense of self. Our experience of being a continuous, coherent individual arises from the brain's predictions about the body and its interactions with the world. The self is not a static entity, but a model that integrates sensory input, bodily signals, and memory into a coherent narrative. This predictive model explains why bodily illusions, such as feeling ownership of a rubber hand or sensing one's body in a virtual environment, can be so convincing. The brain is constantly constructing the experience of the body and the self, generating a controlled hallucination that feels unshakably real even though it is fundamentally interpretive. Sensory hallucinations, whether fleeting or pathological, further illuminate the predictive nature of perception. Dreams, for instance, present vivid, immersive worlds without any external sensory input. The brain is generating a fully self-contained simulation, drawing on memory, emotion, and expectation. Similarly, in conditions such as schizophrenia, hallucinations occur when the brain's predictive models dominate perception to the extent that internally generated signals are mistaken for external reality. These examples reveal that even in ordinary waking life, perception is not a passive reception of information, but an active, anticipatory process in which prediction and sensory input are inseparable. Attention modulates this controlled hallucination. The brain does not process every signal with equal weight. It prioritizes some predictions and sensory inputs over others based on relevance, goals, and expectations. By focusing attention on a specific object or sound, the brain enhances its predictive model for that target, refining the hallucination and suppressing irrelevant noise. Conversely, when attention wanes, the predictive model becomes less precise, and perception may feel vague or incomplete. The precision of prediction shapes the vividness and stability of the hallucinated reality, demonstrating how conscious experience is both constructed and modulated. Learning and experience refine this process over time. From infancy through adulthood, the brain continuously updates its internal models based on prediction errors, the difference between what it expects and what actually occurs. Every moment of surprise, confusion, or misperception provides feedback that the brain uses to improve its predictions. This means that perception is never static. It is an ongoing dialogue between prediction and sensory input, continuously calibrated to create the most adaptive representation of the world. The more the brain learns about its environment, the more accurate and efficient its hallucinations become, producing experiences that feel both rich and reliable. Emotion is intertwined with this predictive process. The brain's expectations are not neutral. They are infused with affective significance, shaping what captures attention and how it is interpreted. Fear amplifies predictions about threat, increasing vigilance and heightening the salience of potential danger. Joy can enhance predictions of reward, coloring perception in ways that make positive events more noticeable. This emotional weighting of predictions ensures that the controlled hallucination of reality is not only coherent, but also relevant to the organism's internal priorities and survival needs. The controlled nature of these hallucinations also explains cultural and individual variations in perception. Different experiences, knowledge, and social context shape the brain's predictive model, producing distinct perceptual realities for different people. What seems obvious and immediate to one observer may be overlooked, misinterpreted, or experienced differently by another. Shared predictions, often reinforced by language, education, and social norms, allow for common experiences, but the underlying process remains a deeply personal, biologically grounded construction. Even memory operates under the same principles. Remembered events are not replayed snapshots, but reconstructions influenced by current predictions and expectations. The brain fills gaps, reshapes details, and interprets past experiences through the lens of what it expects to have happened. In this way, memory itself is a controlled hallucination, informed by predictive models that aim to create a coherent and useful narrative rather than a perfect record of reality. Understanding perception as a controlled hallucination reframes how we think about consciousness and reality. It challenges the notion that what we see, hear, and feel is simply a reflection of the external world. Instead, perception is a dynamic, adaptive, and predictive process in which the brain continuously generates the world we experience. The hallucination is controlled because it is guided by prediction, calibrated by sensory input, and shaped by attention, emotion, and learning. It is reliable enough to navigate life effectively, but its construction is ongoing and flexible, demonstrating that reality as we experience it is a collaborative creation between brain and world. This framework reveals the profound intelligence of the brain, not as a passive recorder, but as an active creator, continuously generating experiences that feel real, immediate, and coherent. It explains illusions, hallucinations, dreams, and memory distortions as natural consequences of a system designed to anticipate, interpret, and respond. By seeing perception as a controlled hallucination, we gain a deeper appreciation of the mind's creativity, the fragility and malleability of experience, and the remarkable processes that allow consciousness to function as both a window onto the world and a construction within it. The sense of self that we take for granted, the feeling that there is an I experiencing the world from a single perspective, is one of the most persistent and convincing features of conscious experience. We wake up each morning with a body and a mind that feel undeniably ours, a continuous identity that stretches backward through memory and forward into anticipation. Yet when examined through the lens of neuroscience, psychology, and philosophy, this self appears not as a fixed entity, but as a dynamic, constantly updated model maintained by the brain. It is an elaborate construction designed to integrate perception, action, emotion, and memory into a coherent narrative that guides behavior. Rather than a permanent, unchanging core at the center of experience, the brain constructs the self using many sources of information simultaneously. Sensory feedback from the body provides one dimension, proprioception, tells the brain where the limbs are. Interoception monitors the internal state of the body, and touch and pressure sensors provide additional context for how the body interacts with the environment. This bodily information is continuously integrated into predictions about how the body should feel, how it should move, and how it should respond to external events. When the incoming sensory signals match the brain's expectations, the sense of bodily ownership is reinforced. When there is a mismatch, the sense of self can become unstable or disoriented, as is evident in certain neurological conditions where patients experience disembodiment or altered body perception. Memory contributes another layer to the construction of the self. The brain maintains a record of past experiences, relationships, and learned behaviors, not as static files, but as networks of associations and predictions that shape expectations about the future. This memory-based model of self allows the brain to anticipate likely outcomes, to plan actions, and to maintain continuity across time. Your current identity is therefore entwined with your past. The self is a narrative that the brain continuously updates, drawing upon prior experiences to predict and interpret present and future states. It is a story told in real time, guided by what has happened before and by what is expected to happen next. The predictive nature of the self also explains why consciousness feels so immediate and unitary. The brain is constantly anticipating sensory input and emotional responses, not only from the outside world, but from the body itself. The experience of I am arises when predictions about internal states, bodily position, and environmental interactions align in a way that is coherent and stable. Disruptions to these predictions through illness, injury, or neurological variation can profoundly alter the sense of identity, demonstrating that what we feel as a continuous self is actively maintained rather than inherently given. The brain's model of the self is therefore flexible, adaptive, and deeply entwined with perception and prediction. Emotion and motivation play a central role in shaping the self. The predictive models that constitute identity are not neutral or purely descriptive. They are imbued with significance and purpose. The brain continuously evaluates potential threats, rewards, and social signals, updating the self model to optimize responses. The experience of fear, desire, or curiosity, for example, is not simply a reaction to events, but a predictive assessment that shapes the self's attention, priorities, and actions. In this way, the self is both a repository of information about the body and world and a functional guide for behavior, helping the organism navigate complex environments efficiently. The social dimension of the self cannot be overlooked. From early childhood, humans develop their sense of identity in the context of interactions with others. Social feedback, cultural norms, language, and shared experiences contribute to the predictive models that define the self. The brain learns not only to predict the outcomes of physical actions, but also to anticipate the responses of other minds. This social predictive machinery helps explain empathy, theory of mind, and social conformity. It also demonstrates that the self is not a purely private phenomenon. It is constructed through ongoing engagement with other agents, embedded in a network of expectations and interactions that extend beyond the individual body. Neuroscience provides striking evidence for the constructed nature of the self. Experiments with virtual reality and sensory manipulation reveal that the sense of ownership over one's body can be altered or transferred. People can be made to feel that a fake hand, a mannequin, or even an entire virtual body belongs to them. These experiences highlight that the self is not a fixed entity, but a model assembled from predictive cues and sensory integration. Similarly, disorders such as depersonalization or out-of-body experiences illustrate that when the brain's predictions about bodily and environmental states fail to align, the self-model can fragment, dissolve, or distort, producing experiences that feel alien despite being generated by the same neural machinery that produces ordinary identity. The predictive self also offers insight into the continuity of experience across time. The brain's model is continuously updated, integrating past memories and future anticipations into a coherent present moment. This allows the organism to maintain a sense of agency, purpose, and intentionality. That plans, decides, and acts is not a separate entity issuing commands, but the emergent property of a predictive system that organizes perception, memory, emotion, and motor activity into a functional, cohesive pattern. The feeling of being a single, persistent individual is the brain's way of maintaining coherence across a constantly changing stream of information and internal states. Language and narrative further reinforce the self model. Humans use words, stories, and concepts to articulate identity, and in doing so, they solidify predictive models that guide perception, behavior, and social interaction. By labeling experiences, reflecting on the past, and imagining future possibilities, the brain constructs an extended, temporally coherent narrative. The self is thus both a psychological experience and a linguistic construct, continuously shaped by internal predictions and external communication. Narrative and prediction are intertwined. By anticipating events and integrating them into ongoing stories, the self maintains stability while remaining adaptable to change. Understanding the self as a biological model also reframes notions of responsibility, choice, and consciousness. It suggests that the I that deliberates, judges, and reflects is not a separate, unchanging agent, but a pattern emerging from the predictive processes of the brain. Decisions arise from the interaction of memories, expectations, motivations, and sensory predictions orchestrated by neural networks that have evolved to maximize survival and adaptability. Free will and personal identity are experienced as real because the predictive system generates coherence and continuity, but they are grounded in the brain's constructive processes rather than in a metaphysical core. This perspective highlights the self's adaptability and vulnerability. It can evolve over a lifetime, shifting in response to new experiences, learning, social feedback, and changes in bodily state. At the same time, it can be disrupted, sometimes dramatically, when prediction errors accumulate or when the brain's models fail to integrate sensory and interoceptive information. The fragility and flexibility of the self underscore that consciousness is not a passive container, but an active, ongoing construction, constantly adjusted to maintain stability, coherence, and functional efficacy in a complex and unpredictable world. By viewing the self as a dynamic, predictive model, we can also appreciate its role in imagination, creativity, and future planning. Because the brain is constantly simulating potential outcomes, it allows the organism to explore possibilities, anticipate consequences, and rehearse actions without immediate risk. The self is both observer and actor in these simulations, integrating past experiences and predicted futures into a coherent mental space. The experience of continuity, agency, and personal identity emerges from this intricate predictive orchestration, enabling humans not only to survive but to plan, create, and innovate within their environments. Ultimately, the sense of self is an achievement of predictive biology. It is the brain's best ongoing hypothesis about who you are, where you are, and what you are likely to do next. It is neither static nor absolute. It is a flexible, continuously updated construct that integrates body, memory, perception, and social context. The self's apparent solidity and continuity are products of sophisticated neural machinery designed to maintain coherence, guide action, and facilitate survival, revealing that identity is less a fixed essence and more a remarkable emergent property of the brain's predictive systems. The way we understand consciousness profoundly shapes how we understand ourselves, our relationships, and our place in the world. For most of human history, consciousness has been treated as a fixed, mysterious phenomenon, a private theatre in which experiences play out, separate from the machinery of the body and the world outside. We assume that awareness simply reflects reality and that the self is a stable entity sitting at the centre of perception. Yet modern neuroscience paints a radically different picture. Consciousness is not a passive mirror of the world, nor is the self an immutable core. Instead, conscious experience is an emergent phenomenon, a continuously updated prediction generated by the brain, a system designed to anticipate, interpret, and respond to a complex and ever-changing environment. This understanding carries profound implications for what it means to be human, for how we relate to reality, and for the way we live our lives. To begin with, recognizing consciousness as a predictive process transforms the way we view reality itself. The world does not simply present itself to us in its objective form. It is actively interpreted and constructed by the brain in ways that are tailored to survival, action, and coherence. Every color, shape, sound, and sensation is filtered through models shaped by experience, expectation, and context. What we call reality is therefore inseparable from the biological system experiencing it. The universe appears structured, stable, and meaningful because the brain generates experiences that are useful, reliable, and coherent, not because it provides a literal copy of the external environment. This means that every moment of conscious life is a creative act in which the brain transforms raw data into the lived world, producing the sense of this is happening in a way that is inseparable from prediction, interpretation, and prior experience. Understanding consciousness as a prediction engine also illuminates the nature of perception and learning. The brain continuously anticipates incoming sensory information and tests its predictions against the signals it receives. When predictions are correct, perception flows smoothly and effortlessly. When they are violated, the resulting errors drive learning, adaptation, and behavioral change. This mechanism explains why humans are able to navigate complex, unpredictable environments so efficiently. Our brains are not passively reacting to stimuli, but actively simulating potential futures, running countless models to predict what will happen next and constantly refining these models based on feedback. Consciousness is the experience of this ongoing predictive process, the subjective awareness of a system that is continuously preparing for what is likely to happen while adjusting to what is actually occurring. This perspective has deep implications for the self. That experiences, decides, and acts is not a static entity, but an emergent property of the brain's predictive machinery. The self is a model constructed from bodily signals, sensory input, memories, and expectations integrated into a coherent narrative that allows for agency, continuity, and intentional action. By understanding the self in this way, we see that identity is not something fixed, but dynamic, flexible, and context-dependent. It can change with experience, adapt to social and environmental pressures, and even be altered dramatically under conditions of stress, illness, or trauma. What feels like a continuous, stable self is the brain's best ongoing prediction about who we are and how we relate to the world, maintained through intricate interactions between body, mind, and environment. Recognizing the predictive nature of consciousness also reframes our understanding of emotion and thought. Emotions are not simply reactions to external events, they are anticipatory states that guide attention, decision-making, and behavior. The brain predicts likely outcomes, evaluates potential threats and rewards, and generates feelings that bias perception and action in adaptive ways. Similarly, thought is a process of simulating possibilities, comparing them to prior experience, and generating predictions about future states. Our inner life, memories, imaginings, plans, and fears is inseparable from the predictive mechanisms that constitute consciousness itself. The mind is always running forward, modeling potentialities, and generating experiences that guide survival, learning, and growth. This understanding also reframes how we relate to uncertainty, change, and novelty. If consciousness is fundamentally predictive, then surprise, confusion, and novelty are not merely external disturbances, they are opportunities for the brain to update its models, refine predictions, and expand the scope of experience. Moments that feel disorienting or destabilizing are, in fact, moments when prediction errors are largest and learning is most likely to occur. In this sense, uncertainty and challenge are not failures of perception or cognition, but integral aspects of a system designed to anticipate and adapt. The more we engage with the unexpected, the more the predictive engine of consciousness can refine itself, allowing for growth, creativity, and resilience. The social dimension of consciousness also becomes clearer under this lens. Human experience is profoundly shaped by interaction with other minds. The brain predicts not only the external environment, but the likely responses of others, shaping communication, empathy, and collaboration. Our sense of social reality, shared norms, relationships, and collective understanding is constructed through these predictive processes, allowing groups to coordinate, cooperate, and anticipate one another's actions. Consciousness is therefore not merely a private phenomenon, but a relational one, embedded in networks of interaction that extend beyond the individual. Our predictions about the intentions, desires, and reactions of others shape the way we experience social reality, and the experience of being known or understood emerges from the alignment or confirmation of these predictions. This predictive framework also challenges conventional ideas about truth and objectivity. What we perceive is filtered, interpreted, and shaped by the brain's models. Perception is never raw or neutral. Reality is experienced through the lens of prediction, meaning that what is important is not simply what exists independently of the mind, but how the mind models, anticipates, and interacts with it. This does not imply that reality is purely subjective or illusory, but rather that consciousness is an interface between the organism and the world, optimized for coherence, relevance, and survival rather than literal accuracy. The experience of being conscious is therefore an ongoing negotiation between prediction and sensory feedback, a dynamic balancing act that allows the organism to function effectively in a complex and uncertain world. Understanding consciousness in this way carries profound philosophical and practical consequences. It reshapes our notions of identity, free will, learning, and experience. It highlights the creative power of the brain to generate the world we live in, showing that perception, selfhood, and emotion are not static givens but dynamic constructions. It emphasizes the interdependence of prediction and reality, revealing that consciousness is both a biological mechanism and a lived experience, an interface that mediates between internal models and the external world. This perspective also encourages humility and curiosity, acknowledging that what we perceive as immediate and obvious is in fact the result of sophisticated neural machinery operating beyond our awareness, and that there is always more to learn about the processes that shape our experience. By embracing the view that consciousness is an active, predictive, and generative process, we begin to see ourselves not as passive observers of reality, but as participants in its ongoing creation. Each moment of awareness is a manifestation of the brain's predictions, tested against the world and continuously refined. The experience of being alive, thinking, feeling, and acting is the experience of a system designed to anticipate and adapt, a biological engine that constructs reality moment by moment. This insight has the power to transform how we relate to our minds, our bodies, each other, and the broader world, revealing the extraordinary nature of consciousness as both a predictor and a creator, a bridge between the unknown environment and the emergent experience we call life.